Welcome to Philotimaths. Today we're going to learn how to integrate basic expressions such as x to the power of n. Let's have a look at an example.
Welcome to Philotimaths, fighting problems one step at a time.
Now, the most important rule that you should know about integration is the fact that it's the opposite of differentiation. So with that in mind, let's look at how we integrate an expression like x to the power of n, where n is just any number. Well, when we integrate this, we get x to the power of n plus 1 divided by n plus 1 plus c. Now this c here just represents any number, and the reason we have to include this plus c when we integrate is for the simple fact that when you differentiate a number, the number disappears. So when you integrate an expression, we have to make a number reappear. So that's why we include this plus c. Okay, let's have a go at these examples then. Now in this first example, we've been asked to integrate x to the power of 4. Now I'm just going to point out this dx here just simply means that it's the x's that we're integrating. X is the variable that we're integrating. Okay, so now let's use our rule that we discussed before. In this example, the power of x is 4. So to integrate this, we're going to add 1 to that power to get x to the power of 5. And then we need to divide by the new power, just like we did up here. We divided by the new power of n plus 1. So we get x to the power of 5 divided by 5, and then we just need to put the plus c. Now just really quickly, I'm going to show you that if we differentiate that, we get back to x to the power of 4. Okay, so we've checked that when we differentiate our answer, we get back to the original question of x to the power of 4, which is good because integration is supposed to be the opposite of differentiation, which means we've done this correctly. On to the next example. Okay, in the second example, the power of x is 2. And again, we're going to use this rule of integration where we increase the power by 1 and divide by that new power. So if the power of x is 2, if we increase that power by 1, the power will become 3. And then we need to divide the expression by this new power of 3, and then we've got to put our plus c. So that's the final answer in this case. I'm just going to quickly show you that that differentiates to get back to the original answer. Great stuff, so it differentiates to get back to the original expression, which means that we've integrated it correctly. Now in this third example, we've got to integrate 5x to the power of 3. This example is slightly harder than the previous two because we've got a number in front of the x to the power of 3. We've got this 5 here. So here's how we deal with that. Firstly, remember that 5x cubed really just means 5 times x cubed. So when we integrate this expression, firstly I'm just going to copy down the 5 times. And then we just need to think about how to integrate x cubed. So that means the power of x is 3, and we're going to increase that power by 1 so that we get x to the power of 4. And then we're going to divide by the new power of 4. And then we just need to remember our plus c. Okay, now we can simplify that a little bit because we don't need to write 5 times x to the power of 4. We can simply write 5x to the 4. And then the remains of the expression is exactly the same. Okay, now I'm just going to check that this differentiates to get back to the original expression. Fantastic, so when we differentiate 5x to the power of 4 over 4 plus c, we get back to our original expression of 5x cubed, which means that we integrated it correctly. In this fourth example, we're just asked to integrate x. Now it's not immediately clear what the power of x is in this case, but remember x really is x to the power of 1, because anything to the power of 1 is just itself. So writing in this power of 1 here is going to help us because it means that we can use this rule up here. So when we integrate this, we're going to increase this power by 1. So 1 plus 1, that's going to give us a power of 2. And then we need to divide by the 2, and then we've got our plus c. So that's the final answer in this case. And I'm just going to show you that that's correct by differentiating this to get back to just x. In this final example, we've been asked to integrate just 4. So there's no x's involved, which means that we can't really use this rule up here. Instead, we've got to use a different rule. Now the rule is, whenever you integrate just a number, in this case 4, the answer is just whatever that number is times by x. So So in this case, the answer is 4x. And remember, we've always got to put our plus c. Now I'm just going to verify that this is true by checking that if we differentiate this, we do actually get 4. Thanks for watching this short introductory video on integration. Now you can finally integrate yourself with all of your friends who know how to integrate. See you next time. Have you suffered from a maths-related injury in the last 4 months?
You're in the right channel. Welcome to Philotimaths.
Welcome to Philotimaths. Today we're having a lesson on integration, and we're gonna do that again. That's what we're gonna do.
Yep.
Now in this second example, the power of x is 2. So according to this rule, I need to increase that power by 1. So that's going to give us x to the power of 3 divided by 3 plus c. And I'm just not going to bother explaining any of that actually. Now the rule is, whenever you integrate just a number on its own, the answer is 4. Depends on the number, obviously.
Whatever you integrate on, it's 4x.
It's just 4. No, it's not even 4x. It's just 4.
It's just 4. Yeah.